Hello everybody, this is dexxcore setting up a basic C++ project. This basic C++ project will be able to use dexxcore, but you can use any library you want. SDL2, raylib, or you could even start creating your own. But before we can create a project, the first thing we're going to want to do is install the libraries. So you'll want to open up your terminal. Since we're creating a C++ project, the libraries we're going to want are G++ and make. Before you install any libraries on your system, you're first going to want to update it. I found that sometimes if your system's not up to date, the libraries will not install correctly, because they're not able to connect it to the server or something. Before you install these libraries, you first want to see if you have them. You can check to see if you have them by checking their version. We've checked the G++ version and the make version, and as you can see, they are not found. And not only that, but it seems like it also shows you how to install them through the command. So sudo apt install G++ and sudo apt install make. I don't know what make gilu is, but you don't need it. Now when you enter this, it's going to tell you how big it is, 180 megabytes, and ask you if you want to install it. Obviously we want to install it or we won't be able to create our project. And then after this we'll install make. The make library is much smaller than the G++ one. Now that we have our libraries installed, we can finally begin creating our project. The first thing we're going to want to do is create the folder. Since everything we'll be doing is inside this folder, we might as well open the terminal here. And open up a text editor. You can use whatever text editor you prefer. For Windows and Linux, I'll be using Visual Studio Code. I'd show you how to install it, but installing it is different on different Linux distributions. But on mine, I just went to the Snap Store and typed in Visual Studio Code and installed it. You may install it by a command like sudo apt install Visual Studio Code, or go to the website. First thing we're going to do is create a main.cpp. This is where all C++ projects start. Now you don't have to call it main or CPP, but it's always nice to just follow the protocol. That way when someone opens your program, they can look at it and say, okay, that's a .cpp, so it's C++, and it's a main.cpp, so this is the entry of the program. We're going to create a basic C++ program so we can run it. I normally like to divide my programs into two different areas, the header and the main function. But first off, you see this number here. It's showing that the file is unsaved. What I normally do is I go to File, autosave. That way, no matter what I type in here, it'll always be saved. Now this is just a main function. It's the entry point of a C++ program. And like I said, I always see C++ in two different categories. You have the base language, which includes if-else functions, loops, algorithms, and arithmetic such as addition, subtraction, and multiplication. Now in C++, whenever you want to have extra useful functions, you'll use libraries. And there are many libraries that are considered part of the C++ language. And one of the libraries that I'll be using is IOStream. IOStream allows you to print text to the terminal by calling the std cout hello world. Some people claim that cout stands for character out, but I have no idea. But now that we have a basic program, we can go to our terminal and call the G++ and target our main.cpp and then .o, which means output file, and we'll call the output file app. And now it's created our executable. We can run our executable in the terminal by just calling the file. Now I'm pretty sure I already said this, but we were able to put \app because our terminal is opened here, desktop new project. For instance, if our executable was in a different folder called build and we wanted to access it, we would have to put build/app and then hit enter. But of course this directory does not exist. Now you could run your program by continuously typing in G++ and app, but that would get very tedious, especially as our project grows. So we'll be using a makefile to automate the process. Now there are many different ways to set up your project, and however, this is just a way that I particularly like to set it up, and it's both set up with my main project and the dexxcore library. You can either choose this ideal, or maybe you've watched multiple other videos about C++ and you just merge them together to whatever fits you. But similar, I also split up a makefile into categories because makefiles allow you to create variables and you can create commands, which I always have the build app command on its own, and then I will have, alright, everything has zoomed in. So give me a second to Alright, anyways, you can have commands, and I normally separate my build app and my other commands into separate categories. How a makefile works is you start off a command like build, then you put the two dots, and then you put whatever command you want in here, which is like the terminal command. And originally in here we typed G++ main.cpp, and then the out file will be app. Now, similar to the terminal's logic, since the makefile is in this subfolder, that is where it will be targeting. So if you want to access folders or outside folders, you have to either put slashes to get to them or double dots, like. But just to show, type in make, it calls this command and builds the app. Another thing we can do too is we could just straight up add it to where it runs the app. That way we can just type in make and it creates the app and then hello world or hello weirdo. And that's it, we're done. I'm just kidding. But this could be it. This could be all you need, but I'm just definitely going to show you what I would, my own opinion, would consider a better setup. And like, remove this, and instead of having, like, for instance, when you call make, it runs the very first, I'm going to call these functions, it commands, it runs the very first command. For instance, if I would have put run here, app, now it's to the point where if I type in make, it's going to call the app and run it. And if I was to remove this, just to give you a more example, now if I call make, it can't build it because it didn't run it, because what make does is it comes down the line, finds the first function and calls it. Now since build is the second function, if we want to call it, we have to make build, and then we can just call make to run it. It's kind of an order thing. But just move this down to commands because that'll be our run command. But another main thing you can do is, what make really does is it comes down to build and it says, hey, in our folder does a file named build exist? It does not exist, so let's create it. Now since this command is creating app and will never create build, build will never exist, so in a way it just will always call it as a function. For instance, if I was to put app in there and remove this and then I call make, it'll run like normal and run the thing. But now if I call make, it says app is up to date, meaning that it didn't even run the command because make went down, found the first function, and says, does app exist? App does exist, so let's not build it. Now another thing I like to do is, over here in make, like for instance right now it says app is up to date, and I go to make here and I change it, right? And then I come in here and I hit make. It still tells me my app is up to date, but that is not true because I changed this phrase and took the O out. Also, how make files work is you have the target that you're building, which is our app file, and you also have dependencies. So what we'll do is we'll add main.cp as a dependency. Our app file depends on a main.cpp file to be created. And now that we've added this dependency, if I type in make, it'll build the application. And if I type make again, it says it's up to date, but the moment I come in here and I change that O and try to make it again, it'll actually build it again because the file's changed. Because Windows and Linux and all operating systems, files have a date of when they were modified, and I believe make files access that time mark. But either I don't know how it does it exactly, but either way, Makefile is smart enough to be like, hey, this app file depends on Makefile, and Makefile was changed, so let's rebuild it. And now that it's built, it's up to date, let's not build it. And then, of course, you know, we can call our command make run and run the program, or you could just slap it underneath. But I tend to like to have commands for different things. But this is the basic. But how I set up a file is I'll create variables. One will be app, and it's technically the app's name. So, like, slap that with app and move to trash, and that way now I can say make, and it will. Is it not cap sensitive? Oh, no. Okay, so basically you have to put app down here as well, and whenever you access these variables, they have to be, like, for instance, this is a variable holding app, the text, and if you want to use this variable's value, you have to incorporate it with a $sign in these. And now it'll be called app, and you know, I could change this to anything. And hit make, and now it'll just be called Zenity. But I normally don't like my project executable to be built in the same folder or area as my, I don't know, I just like to organize things, and how I do it is I'll create a folder called build, and this build folder will be where my project builds, and I'll also create a variable holding that. That way, if someone wants to rearrange or change the project, like, for instance, like change names and stuff, you can, like to give an example, let's say that now I'd like my Zenity app, which I'm going to go ahead and just go back to app, just for generic. But I want my app to build in my build directory. Build directory. There we go. So then I hit make, and it builds in there. And of course, now we're also going to need to add that here. And honestly, we should just copy this, because now, no matter what we change our build directory or app name to, the app will always build correctly and the run will always run correctly. It won't even matter. And that's the main point I'm trying to get across of why these variables are nice, because now you can change things and not have to worry about the commands. But another thing is this build folder is your entire app. Your finished product is in here. Like, this is the folder that you would copy and send out to someone if you wanted to share your program. And maybe, like, you know, first you start out with generic app and builder, and then maybe you've created a game called RPG. And honestly, at this point, it would make sense for you to have your folder called RPG. That way, when you make the project, or when you make the game, and you test it, then all you gotta do is just copy this to somebody, Or you could zip it up and just send it to somebody. I know I'm probably overcomplicating this, but the point is I really want you to know how this basic project works entirely, because that's what's going to make you comfortable enough to use it and, you know, be able to create new things. And, you know, if I just shot a bunch of code at you that you didn't know what it did, then you really wouldn't feel like this project is yours to add, expand, and do whatever you want with. Now, there's this... Okay. So, I've got other variables, and we're going to have a folder called scripts. And then within that folder, we're going to have another folder called sources. Basically what this is the ability for you to add functions to your project. For instance, main.cpp here has a function called main, and it's a .cpp. So what you would do in the scripts folder, actually, I mean, I'll describe scripts when I'm doing it, so it's easier. But the main thing we're wanting here is this source folder. Because originally how we compiled our main.cpp into a executable, we're not going to want to do that. We're going to want to compile our main.cpp into objects, which is binary code. And then when it comes time to build the app, we're going to compile all those objects files from our CPP files into an executable. That way our program will be able to have the main CPP and any functions we add. But before we do that, we'll need to be able to list these. And here's these two. Now I know this looks scary, or at least confusing, but all it really is saying is we have an app variable called app source, and we need this app source variable to be a list of all our CPP files that we want to compile in our program. For instance, we have main CPP, and in our scripts we may have a created CPP, pretty much okay, recap. So we have our app sources, and we want this to be a list of all CPP files we want to compile in our program. And of course we've got the main CPP, which is the entry, but we also have our own CPPs that we've created by ourselves, you know, add functionalities or whatever we want to add to the program. And we need a way to get these, and you have the wildcard command that acts like a function, and similar to our variables, to access this you're going to want to enclose it in a $sign with brackets. And what we're basically saying is wildcard is saying that it's a function that lets you give an address for instance scripts directory. This is the directory of the scripts. So we're going into the script directory and we're getting all the .cpps that exist. And that's what the star does. For instance, the wildcard function says get a file, And we could put function.cpp directly. And what it would do is it would go through and get the function CPP and put it in the list. But if we put the star, what that means is inside script directory, which is here, every file that ends in .cpp will be put in this list. That means if I was to even go in here into the scripts and create another CPP file called memory functions or string functions, which is how dexxcore creates his libraries, it will automatically be put in this list. And then not only do we want to include the scripts in our project, but we also want to include the main.cpp. That's how that works. And then you have this app object list, which is basically the exact same list as app source, but we want it to be in the source directory. And instead of having all of our files end in CPP, we want them to end in .l. So what this is saying is path substitute. Now, these locations consist of a path, a file name, and an extension. And we're wanting to path substitute our scripts directory with our source directory. And then we want to get a new list of not directory, which means that it takes our app source list and doesn't include the directory of all the files. So then we'll have a list of just files. And then what the .cpp equals .o means is in this list, in this function here, because $tree, this is its own function, we're taking the app source list, removing the directory, no directory, so then we have just file names and extensions, which are all .cpp, and then we're taking all the .cpps and making them equal .os. So now we've got our list of app sources, but instead it's just their file name with .os. And now we're substituting we're substituting the list's directory with source directory. So this ends up giving us the same list of files in app source, but instead they're located in script source and ends with .o. I hope that makes sense. It is kind of crazily explained. But in the end, I mean, once you have this code, you don't really need to understand it. And we're going to remove this. And this is similar to before. The only difference is this is the target. And this here is the dependencies on the other side of this mark. The target is always the file you want to build. And right now we're wanting to build a file in the build directory and have it be our app, which is this. And then we could come down here and type in our command G++. Now, there's this symbol $up. What this basically says is up here in your title, you have your target and your dependencies. This basically takes whatever's in the target and just fills it in. So that means our app that we're trying to create is being created here. And then of course, since it's our output file, we're going to put the O. And then okay, I was wrong. I misled you here. This is not the right symbol. Okay, so what we do here is our out file. The file we're trying to create is our app program in build directory.app. And then we use the $. Oh, what this is this takes all the targets or dependencies, because this is the target, this is the dependency. And this basically replaces itself with whatever's in the dependencies, such as last time we had main.cpp. This would be main.cpp. But in our actual build app, like I said, instead of just building from one .cpp file, we want to build objects. So we would actually put our object list here, which lists all the objects we want to be built in our app. And so that's basically it, you know. You call G++, the output file is the app name, and then we include all of our objects that we compiled. But we do have to compile these objects. And what this app does is it's similar to when you come down, like when you type in make and it comes down to the first command, it says, does this exist? And if it doesn't exist, it calls a script that's supposed to build it. And if it doesn't build it, then that's just considered a function. But this is similar. It's going to go through each object file and try to build it. And it's going to try to find it in here. And right now we don't have any definitions for building those object files. So we'll create our first definition for building the main CPP. But we also have one that builds our script objects as well. These two are basically a copy of each other. What it's saying is our target. Our target file, which is our app object, and our source directory. So that means that we want to create named file in our source directory right here. And to give an example, I can compile this real quick. So like we're in our source file right now. So I'm going to type make. It made them both. Oh, that's right, because I got this in here. But as you can see, it created a function object and a main object. The reason why I did that is because we have a list of our objects here. Actually, give me a second. I wasn't going to add this, but I think it's going to be very helpful. But basically, down here you have your commands. I'm going to create one called info. And what this is going to do is this is going to print the app source list onto the command or the terminal. Make info. Now, as you can see, this app source is exactly what we said. It's got the script directory slash and any CPP that's in there. So now it's got scripts functions.cpp, and we just casually added main.cpp at the end. For instance, if I go into scripts and I create test.cpp and then I run the info, it's going to automatically add in function.cpp and test.cpp. And the reason why this is handy is that means this makefile can be coded once, and then you can close it and never have to worry about it again. And all you have to worry about is coding your project and coding your functions. And that's really what I want to go for, is something that is self-containable. You know, I don't want to have to keep going back to this makefile and be like, oh no, you know, the project changed, I added so much, and now I've got to modify it. No, I mean, the only way that this would probably change is if you add dependencies, like, for instance, a dependency to include OpenGL, or, I mean, OpenGL is the only thing I've ever used that's dependency. I mean, OpenGL and Vulkan, they're both graphics libraries. But you'd come up here and you would just type OpenGL. Oh wow. Okay, OpenGL equals, and you would put whatever is needed for your dependency, and then at your build app right here at the end you would just $OpenGL, and then technically your dependencies would be included in your app build. I know this video is crazy long. Like, honestly, it's pretty crazy, but like I said, I'd rather you fully understand this. But anyways, back to our list, and now that you kind of see that it includes whatever I put in here, I'm gonna go ahead and remove test, make info. And then I'm going to add the object list, make info. Now, as you can see, path substitute with source script sources. So now everywhere you see the script path, it's going to edit it script sources. And if test was still in here, it would also be test script sources / test.o. And the reason why it's a .o is because .cpp equals .o. All these .o's have been replaced with the .cpp. And now that we have a list of our objects we want to build in the source folder like we were wanting, now in our app build here, we put that app object list, which is essentially this, and it goes through each of these objects and builds them. And what it does is it comes down to our other build commands, and it sees if it fits. For instance, source directory is script sources. Okay, the function object fits that, but so basically it sees what it wants to build, and both of these functions and main O are indeed in the source directory, but their location in folder, their actual CPP file, is different. For instance, this doesn't indicate a directory, so that means that it will search for any CPP that's in the main folder, the base folder where make is. And when it looks for function.o, it won't find it. So then it goes to this one, and it says, okay, source directory.o, this is the target we're trying to build, with the file name, function object. Now, let's search for a CPP that matches function in our script directory. Luckily, it's found, so it will build the script. But it basically comes down to where the makefile is built from this one because main, or the main file is built with this one because main is in the sub, and any CPP that exists in the script directory is built with this one. So that means every one of your scripts you add into this project will be built by this command. So really the only difference between these two commands is the directory in which they're trying to access the .cpp. Other than that, they're identical. Now, when we call G++ for the sources, this time we call /c, and I like to believe it means compile, but I don't know. But what this does is instead of compiling our stuff into an executable, it'll actually compile it into an object. And since this one above here doesn't have the /c, it compiles it into an executable. And now that we're compiling these into objects, which are in our sources, which are binary, which you can see by these cute little binary icons. And what this symbol does is it replaces itself with the requirement. And this is the target. We're trying to create the source directory script name.o, or just file name.o. And the requirement is the file name source file, which is CPP. So what it does is it'll take this and put it here, place it here. So now we're compiling our file source file and we're outputting it to the target, because what this symbol does is it takes whatever is in the target and it just pastes it here. Yeah, we could easily take this .cpp, copy paste into here, and then we could take this and paste it right here and it'd be exactly the same. But this is just a shorthand to make it more readable, smaller. And I mean, I guess it would suck for someone who got in here and didn't know this, because they're like, what is this crap? But I mean, now you know. This just takes whatever's in the target, pastes it down, and this takes whatever's in the source. And this is similar to this. It's just the difference is this is meant for targeting, grabbing one file from the dependencies, and this will drag all the files, because like this is a list, and I'm pretty sure you could put this down here and it would work. I don't know, but the point is this one specifically, the definition is replace with requirement, and this is replace with all requirements, because this is a giant list. But anyways, back to the build app. I know this has been crazy, but we target building our application of name and directory, and then it sees its dependencies, and it goes through the list and calls their build functions to whatever matches in here. And then finally in our source folder, when we finally have all our objects compiled into binary, we'll finally build our application with G++. The output will be our target, and honestly we could use the same thing here, actually the same thing here, to grab our target and shove it down, but there's no point. And then this here includes all the objects we built. So essentially, we're building our app, and we're building our app with all the objects that we've created to get our final application executable. And that's pretty much it. And besides calling the run, now there is something else I like to do. I like to have a clear, because if you've been watching, like when I show you this, I have to completely like delete that, and you know there's these sources, like similar to how we go to our build and we've built it and we type in make and it says that's odd. Huh. I don't know. I expected it to say we're all up to date. But I do know, even though it doesn't say it, which it's probably not saying it, because here's the reason why it's probably not telling you. Is because if we went to our scripts and we had like 5 functions, 5 function sources that compiled into 5 objects, it would be telling us everything's up to date 5 times, and that would be very just cumbersome. Like, you wouldn't want to see that. But similar to it being targeted, and if the CPP file is unchanged, it doesn't rebuild it. A lot of times when I want to completely freshly rebuild my project, I'll delete these and I'll come into my build and I'll delete this. That way, when it's time to build the project, I know that it literally had to, like, yeah, here's an example. See where it built this project? And it built our O function, our function.o, our main function.o, and then it built our application. Well, now that these O's exist, if we were to type in make, it will no longer build the function.o and the main.o. As you can see, the only thing it builds here is the app. And I'm pretty sure if I change something in here, it'll try to build main again. I hope. Yeah. Nice. Okay. So yeah. It'll build main again because we changed it. But anyways, this setup's really cool because now you can test your program and not waste time compiling stuff that you're not changing. But the main point I'm getting to is there are strange incidents where, like, for instance, actually, before I can talk about this, I need to really... Anyways, for now, just know... Actually, let's just do that real quick. Okay. We're going to go in our scripts, and we're actually going to create our function. How this works is we'll just create a function called add. It returns an int, so we might want to return that. And we're going to want to have arguments A and B. And since this function adds them, we're just going to return A plus B. Pretty simple. Now, when we compile this code, this function object is into our application. Like, this application consists of our main object and our function object. And the thing is, you know, we're here in our main function, but how are we going to call our add function? And how you would do that is through headers. Because in the end, function add already exists in our application, but we need a way to access it in our main. So what we'll do is we'll create a head or a header, call them my functions, and declare our function int. And then we will include that header into our main CPP. And now that we have, because what include does is it will go into your function.h, because if you notice, function header files are not compiled. Only CPPs are compiled. But what headers are for is for taking this entire thing, copying it, and wherever it sees include function h, it will literally just paste it in there. But the ideal is your function object could have hundreds of functions, and you don't want to add in or type every time you want to include your function somewhere into your main.cpp. But the problem I've ran into, and honestly, now that I've taken the time to explain this to you guys, I understand it better myself, so I can fix it, is that in a makefile, when you're compiling your objects and the dependencies change, it rebuilds the object file. Well, the thing is this H file is not a dependency. That means that in my main right here, I rebuild it real quick. I see what happened. Okay. Normally, what I do is I will have include directories, and when you're building your object files, you'll just add include directory to include the directory into your object, because what's happening here is when our object file is building, it's going to where the source codes were located. For instance, our main file is here, so it's searching here for all of its stuff. And our script file, when we build our script.cpp, it's searching for all the stuff here. To give an example is right now it won't build. So if I was to copy this header file into our main CPP folder, it would work. But we don't want to do that. we'd like to have our program smart enough to know. And to be honest, there's only two locations here. There's the main CPP, which is here, and there's the script. For instance, our function CPP can include the function.h because they're in the same subfolder. But what I do to fix this is there's one simple trick where if I compile it now, well, if I compile it now that I've removed functions, the function.h from the main CPP, it won't do it. But what we could do is we could tell it, hey, this is our main file, and the function.h we're looking for is in the scripts directory, and that would work. But I like when things work for me. I don't want to sit here and say, okay, where's this function thing located? Where's that? I just want it like this. So what I do is I go into my main and I go include directory. Whether you're building a main file or you're building a script file, always include these directories. And this directory is going to be our script directory. And if you had any other directories, you would include them as well. But not like 99% you are not going to need a function. There is no main header. There's no main header. So as long as the main CPP, the main CPP and any function CPP is aware that the script directory exists, the script directory that has all the headers, you're fine, because now that we've added that, give me maybe. Yeah. Okay. So yeah. Okay, so so basically I forgot, when you want it to be an include directory, you're supposed to put a capital I in front of it. That indicates it's an include. So right now we just added scripts, but the make file doesn't know if that's supposed to be a file or what. But when we put the backspace I on it, we're telling makefile this is a directory, and we want you to be aware of it, because in our program we may tell you to include a file in that directory. So now that we put make on it, it works, and as you can see, it builds it with that I on it. Now, one thing that kind of sucks is you can see that I included this new include directory on both my main and my script functions, but yet it didn't rebuild the script. Which, I mean, I guess technically it doesn't have to, because I don't include anything, and, if I was to change something, like, it would rebuild it. But I guess my point is you build the makefile, and it doesn't build the main object or the function object because they're the same. I could come into function.h and change this to C, the header, and go to make, and it does not register the change at all, because in the makefile the header is not a dependency, because when make builds these executables or objects, what it determines if it needs rebuild or not, if a dependable is changed or not. And headers are not dependables. I mean, you could put them in there, but I can't really see a I really can't see a fair method of doing that doesn't make the makefile become something you have to manage. And like I said, I like to have the makefile where it, once you build it, it doesn't exist. You know, you just close it and you just build whatever. You know, you add a function object, you add a header, you want to access it somewhere, you include the header, and then you can call all your functions. Makefile will not exist. You don't ever have to worry about it again. And honestly, the ideal is if you deeply change a header or something huge on a function script, you should probably just delete your app executable and delete your object binaries. But that gets me to the next thing, clear, which is basically this here is changing the directory that makefile is targeting, and it's changing it to our source directory here, which contains all our objects. And then when we're in that folder, we call rm, which is remove, and we remove all .os. Now, I can't exactly remember what this, I think F stands for file, and maybe D for directory. I really think that's it. But in the end, it doesn't matter. I mean, you can always look it up. You know, Google it, remove/F, and it will show you what it means. But I'm pretty positive it means file and then D for directory. But the point is now in this source file, if I just say make clear, it will delete all the objects. That way, when I build the project, I know that it's a fresh build and every single object is going to be rebuilt. Because like I said, there are those rare times where you've changed a header file, it's not considered a dependency, so then your object files that use the functions don't update, and then when you call, I don't know, it's kind of hard though, because like honestly, if you're gonna change a function, you would probably change every code that uses that function, because you know I just changed that to a B, which I don't think that's relevant, but I don't know. So far, I don't see a problem with it, so I just ignore that loop. And so far, when you go to build, it doesn't clear your app executable. But I've come to the conclusion that no matter if this exists or not, it's going to rebuild it. I know that kind of went against goes against what I said, where it says, hey, does this app exist? If so, let's not do anything. But I don't know, it's weird. Maybe the rules change whenever a target has dependencies that are called upon by commands. But all I know is originally when we just had our app at a very basic target CPP file and create an object, it would not compile itself again if there was no change in the dependencies, similar to what these do, because these are just basic CPP files being compiled into objects. But now that this target depends on objects to be compiled, it compiles every time. But I don't really know, but I do know it works exactly how I've shown you. But anyways, the point is we have info here, which will allow us to make info to look at what these are, because I don't know, maybe you've added a bunch of stuff, you've changed stuff, and there's a problem and you need to debug it. Well, now you can just call this and see what these hold and why things aren't working out, and then you can run it. You know, you might even just be like, you know, every time I run this bad boy, you know, but what I do too, like, is you have run here, and it checks to see if run exists, it doesn't, and then it calls it. But another thing you could do is have run depend on the project. And what that means is if you didn't have this here and you went to your build and you deleted this and you type in make run, it'll cause an error because it's like your project does not exist. But what this does is it'll say run, but we depend on the app project to be built. So build it, then run. So now, even though we deleted the project, and we hit run, it will build it and run. And that's much nicer in my opinion. And then we created the clear, which basically clears all the created object binaries, so that we can have a clean build. And now that everything's cleared, if we run make run, function object, main object, all objects are rebuilt, and then the main app is rebuilt. And of course, since we called make run, since we called make run, it also ran it with weirdo, which I guess I gotta put the O back. But anyways, the main point here is we've just created in our scripts a object with a header that has a function. So let's call it. And you know, I'm just gonna come into the description and copy it. 3, 2, which equals 5. And now, if we come to make run, oh, that's right. Okay, so it's just not showing anything new because we didn't output the variable. So we might want to do that if we want to see any results. Okay, and 3, okay, our add subtracts because we changed that. But another thing I want to show you, actually no, I think if we add this plus, main should be recompiled. I meant to say make run. Yeah, okay, cool. So the only weird flaw to the setup, which I really don't see it as a flaw, is headers. Makefile is unaware if headers change. So like, you know, if you've done some heavy modifications to headers, which probably could be dependent on multiple objects such as your main or other functions, because you know, you'll have, like, for instance, my memory functions are used in every one of my other dexxcore functions because memory functions are so primary. And then on top of that, you got the memory functions, the string functions, and memory, string, and data structure functions are used everywhere. So when you come in and you completely rearrange and rebuild the library to where the H file, its mom won't even recognize it, you're better off just going in and saying make clear. And that will remove all the objects. You can make run, and it will rebuild your entire project. And I mean, you can add your own other functions. There are many things you can do with command line, like commands, or there's a lot of things you can do with terminal commands, but so far I haven't needed any more than these basics. And I mean, essentially that's it. That is the C++ based project. And the point is in my project I will have like I include dexxcore, but you know, you can use whatever you want, SDL2, raylib, or heck, here you are, start creating your own functions. Because thing is like, we use this IOStream include function, and you know, when I use this IOStream function, I only use stdcout. And I can tell you right now, this function's huge. Like, this function has a lot of crap in it. And that's why I prefer, when I'm coding, that I will only use the basic C++ language, and I will not include any other headers unless I've created them myself, because now I know, you know, I use this function header for add, and when I go in here, I know for certain there's only add. There's no other functions and like billions of lines of code I'm not using, because I want my program to be very basic, simple, and to the point. I don't want extra stuff in here. But basically, this is it. I hope this is useful to you guys and you enjoy it. But I also remembered we got to do this on Windows, which technically Windows is exactly the same. So I don't know if it's worth going through it again. But, I mean, geez, you're going to take forever to shut down? Okay, anyways, get this out of the way. I have my Windows project right here. Oh. Anyways, I have my Windows project right here. It's pretty much built the exact same. I have my Visual Studio. You know, you come into Make. You have your IOStream, scripts functions, hello weirdo, and then your add function, and then in scripts you have your functions. I haven't added the but the main difference in here in the make file is literally everything is exactly the same except for the clear function. In the Linux clear function, we use the keyword remove/f. In the Windows version, we use del, which means delete, and then $$. Other than that, it is literally cross-platform. It's exactly the same. The only difference, you see this here? This could have been done in Linux too. This is basically, you're supposed to use this to declare your functions, such as run, clear, clear lib, clear all, clear run, but this isn't even required. And there's no point showing you it if it's not required. Like, I have no understanding of why it's there, besides just simply giving someone a list of the functions they can call. For instance, run, run, clear, clear, and these are normally there, but they're not. But, yeah, that's basically everything.